We saw that with something that is linear, a highest exponent of 1, the difference quotient is just the coefficient every time. But what if I have something with a higher exponent than just a 1? Let's look at one that's got a square to deal with. We're using the same difference quotient formula, applying this on this problem to f of x is equal to 5x squared. Now here in the red is the first part of our difference quotient formula. I've taken x plus h, replaced the x's with it. So this 5 is that 5. Instead of this x, let's put in x plus h, and all of that was to be squared. That's the first part of the top. Back on the back, the stuff that is in blue is minus f of x. It says opposite of f of x. Opposite of positive 5x squared is minus 5x squared. All of this is to be divided by h according to our formula. Now from there, the next thing for us to do is to square the binomial. You probably want to go ahead and memorize that x plus h squared will result in x squared plus 2xh plus h squared, because this is going to happen anytime that you have a square involved. Where that comes from, take the first one and square, multiply these together and then times 2, then the back one squared. First one squared, multiply them together, then times 2, and last one squared. This binomial squares to be that product. If you have trouble trying to remember that, and if you have trouble trying to actually square it out, feel free to do x plus h times x plus h and FOIL it. You'll get the same result. From there, let's bring down the minus 5x squared. Now here it's telling me I should distribute 5 into the parentheses. So as we do that, 5 times everybody here, 5 times x squared made 5x squared. 5 times 2xh is 10xh. 5 times h squared is 5h squared. Bring down the minus 5x squared on the back. Now, just like we saw with the linear problems, once we're to this next to the last step, anything that fails to have an h needs to go away. Only things with h's can remain. So the 5x squares had to add out. Everybody that's left has an h. Since they've all got an h there, I can factor an h out on the top. Now it's true that there was more than just an h that was common, but it's only the h that we want to take out so that the h can cancel with the h on the bottom. Our solution then, when you've divided everything on top by the h on bottom, would be just 10x plus 5h. Let's see if we can find another one. On this next one, same formula again that you should commit to memory. This time we'll apply it to minus 10x squared plus 1. The first part of the top says x plus h in for all of the x's. So the minus 10, let's bring it down. Instead of this x, let's replace it with x plus h, and that was to be squared. Then back on the back is the plus 1. What I've written so far is just the first part of the top of our formula. Now it says minus f of x, the opposite of f of x. What's opposite of minus 10x squared? It's plus 10x squared. What's opposite of positive 1? It's negative 1. All of this should be over h. Now again, we've got this binomial to square. Hopefully you remember from the last one, it's the first one squared. Multiply these things together and then times 2, and the last one squared. Again, if you don't remember that, you can always fall x plus h times x plus h. But this is where you'll go every time that you have a square involved. Looks like my 1's cancel out and there's no need to keep them, but I do have a 10x squared that I'll need to bring down. Let's distribute minus 10 into the parentheses. It's minus 10x squared minus 20xh and minus 10h squared. When I distribute negative 10 into the parentheses, it gives me this. Bring down the plus 10x squared that was on the back, and all of this is still over h. If you're going to make it to the next round, you have to have an h. That means this needs to add out, and it does. I'm left with minus 20xh and minus 10h squared. All of this is over h. Everybody here's got an h. If I divide this h into everybody that's on top, I would end up with minus 20x and minus 10h. This is our difference quotient. Dividing both parts by that h on the bottom gives me minus 20x minus 10h. Now, if you're like me, you miss the days that you could just look at the coefficient and see what the answer was going to be. You'd like a fast way to be able to get these, or at least know that you've done it right. There is a fast way from calculus called a derivative. To do a derivative, take the exponent, multiply it by the coefficient. So 2 times minus 10 would be minus 20. Now take the exponent and subtract 1 off. If you subtract 1 from 2, you would be left with an understood 1. The derivative won't give you the h part, but it does give you the part that's still got the variable attached. It's exponent times coefficient, subtract 1 off. So that minus 20x is pretty close to being what our difference quotient solution was. This gives us a way to know how to check to see if our answer is right. We can do it very quickly that way.